Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series. So as you all know, we have started a series where we are going to cover each and every concept that is going to be asked in your KCET Chemistry examination, as well as we are going to solve all the PYQs and practice a lot of questions so that you can master your chemistry and can hit that perfect 60 out of 60 score. So yes, in today's video we are going to discuss part 2 of electrochemistry, where we'll be covering the topics electrolytic cell and electrolysis and conductance of electrolytic solution. Okay, so the part 1 of electrochemistry is already done, where we have discussed galvanic cell and Nernst equation. So if you haven't watched that video, please watch that video also. The link of that will be there in the description section. Now one more important announcement here, or I'll say request here. So please join our WhatsApp channel. It is very important because all the class notes and the questions will be available in our WhatsApp channel. So please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video. So you can go to the description section, click on the link and join the channel so that you do not miss out on the notes or questions or any other thing. Okay, so yes, now let's get started with our today's topic, that is electrolytic cell and electrolysis, conductance of electrolytic solution. Okay, so now coming to a brief, like how are we going to cover this chapter. So this chapter I have divided into 3 parts, part 1, part 2 and part 3. Okay, and in part 1 we have already covered galvanic cell. Okay, we have already covered galvanic cell and Nernst equation. Next, in part 2 we are going to cover electrolytic cell and electrolysis, that I already told you, and we'll be covering conductance of electrolytic solutions. Okay, now coming to in part 3 we are going to cover batteries, fuel cells, and you will be covering corrosion. Okay, so now let's get started to understand what is the weightage of this chapter year wise. Okay, so I have already discussed in the part 1. So every year from 2017 to 2024 you can easily expect 3 questions from this chapter, right? So that means you will be easily getting 3 marks from this chapter, right? So yes, this is a must do topic and a very scoring topic. Some students might feel this difficult, but you can just focus on particular numericals, particular formulas, then definitely you can score full marks. All the 3 questions you can solve from this chapter. Okay, so just you need to follow some basic strategy here. Okay, now coming to today's electrochemistry part 2. So I'll be discussing electrolytic cell and electrolytic conductance, as I already told you. In electrolytic cell we'll be discussing first Faraday's law, then we'll be discussing products of electrolysis, and then we'll have a small comparison between galvanic cell and electrolytic cell. Okay, and then coming to electrolytic conductance. So here first we'll be discussing factors affecting the electrolytic conductance, then we'll be talking about some important terms, their definitions and symbols. This is very important because many a time students get confused with different terms and symbols. Next we'll be covering some important formulas, then we'll be talking about variation of molar conductivity with dilution, and lastly we'll be covering limiting molar conductivity and Kohlrausch's law. Okay, so yes, with this we'll start today's lecture. So I hope you have understood what all things that are we going to cover. So I want everyone to sit with a notebook and a pen and note down all important formulas and concepts. Okay, so yes, now let's get started. So first of all, now coming to electrolytic cell. What is an electrolytic cell? So as we know, in electrolytic cell the electrical energy is converted to chemical energy, means you have to provide electricity, as a result of which some chemical reaction will take place. Okay, now it is a non-spontaneous process. Obviously it will be non-spontaneous process because we are supplying energy from outside, right? Which is this form of energy? That is your electrical energy is supplied. Okay, next coming to delta G will be positive here because it is a non-spontaneous process. Next, in this case the anode is positively charged and the cathode is negatively charged. Okay, and then example, it is used for obtaining pure metals. I'll be talking about this also. And one more point we can write here, that the cell which contains your electrodes, okay, electrodes and electrolyte are present in the same container. Like how in galvanic cell we have 2 separate containers, they are present in single container. Okay, So this is one important thing that you need to remember, that electrodes and electrolytes are taken in the single container for electrolytic cell. Now coming to next one here, that is Faraday's law. Okay, so in Faraday's law we have two laws, Faraday's first law and Faraday's second law. Okay, so we'll be discussing both the laws here. So coming to first, Faraday's first law. Okay, so what is the statement here? The amount of chemical reaction which occurs at any electrode during the electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte. Now let us understand it in simple words. See what I told you, what is the definition of like Faraday's, what is the definition of your in electrolytic cell? In electrolytic cell, what I said, the electrical energy, right, is converted to chemical energy. Okay, so in that case, what does it mean? Electrical energy is converted to chemical energy means, now what does Faraday's law say? That if more electrical energy is produced, if more electrical energy is given, in the same way chemical energy or the chemical reaction that will take will also be more. So simply it is said that whatever quantity of electricity you are providing, that many amount of chemical reaction will take place. Okay, so the amount of chemical reaction is proportional to the quantity of electricity passed. The amount of chemical reaction is proportional to the quantity of electricity passed. Okay, now let us see the formula for this one. So here formula is M is equal to ZIT. Now what is this M, Z, I, T, everything I will explain. So now see what happens basically in a electrolytic cell. Let us first understand, then we will understand what is this M. Okay, so for that let us draw a diagram. Okay, see what happened, I told you in this one we take both the electrodes in the same electrolyte. Okay, now what happens here if we take, okay, now here we have taken any electrolyte, okay, A plus and B minus, let it be A plus and B minus. So and then this is connected. Okay, so I'll tell this is anode, okay, positively charged, and this is cathode, negatively charged. Remember the sign convention here is opposite to that of your galvanic cell. Now what happens here, the positive electrode, the positive cations, I'll say positively charged ions will move towards the negative electrode and this one will move towards this one, right? Then here what will happen, here always you remember I told you cathode means reduction takes place and in anode oxidation takes place, right? So now what happens here, there will be reduction. So what will happen, this A plus will gain a electron and will convert it to A, right, solid. So this A will deposit here, right, this A will deposit here. So this is the M that we are calculating here. What is that? Mass of A deposited. Okay, mass of A deposited is calculated here. Okay, now what is M? M is mass of metal deposited. Okay, now Z, what is Z? Z is called as electrochemical equivalent. Z is electrochemical equivalent. Okay, then I is equal to current and T, small t is equal to time. Okay, so now you see what it is saying, that M, okay, M is proportional to the amount of current or the amount of electricity passed. Now Q we can write it as M is proportional to I into T, right? Now to remove this proportionality we multiply with a constant, that is electrochemical equivalent, and we get M is equal to Z, I and T. Now how to calculate Z? Z is very simple, molar mass divided by N into 96500. Now what is this N here? N is the number of electrons used. Okay, so we'll do a question from here, then it will be very clear. Okay, okay, now let us first finish the Faraday's second law, then we'll do question from both first law and second law. Okay, now what does Faraday's second law say? The amount of different substances liberated by the same quantity of electricity passing through the electrolytic solutions are proportional to their chemical equivalent weights. So what does it say? That when you are having two containers, okay, this is one electrolytic cell and this is one electrolytic cell, okay, and you are passing same amount of current to both of this, okay, and here there is A plus and B minus, and suppose here it is C plus and D minus. Now what will happen? A will deposit here and C will deposit here. This is your anode, right? This is anode, this is cathode, this is anode, again this is cathode, right? So now what does it say? If same current is passed to both the electrolytic solution, then the amount of different substances liberated. So here what will be liberated? A and D, right? A and C. So A and C will be liberated here, right? The amount of different substances liberated by the same quantity of electricity passing through the electrolytic solutions are proportional to their chemical equivalent weight. So that is, I can show you in the formula, M1 by M2 is equal to E1 by E2, or I can say, if here I want to say mass of A by mass of C, mass of A deposited by mass of C deposited is equal to the equivalent weight of A by the equivalent weight of C, okay, equivalent of weight of A by equivalent of weight of C. Now how does we get this one? So let us do it very simply. Mass of A deposited will be what? ZA, okay, into I into T. Mass of C deposited will be equivalent weight of C into I into T. Why I and T are same? Because same amount of current is passed. Now I take a ratio of both of them, then IT will cancel. What I'll get? ZA by ZC. So if I write this one, MA by MC, okay, is equal to ZA by ZC, right? Now what is ZA? So what is ZA here? Molar mass of A, right, divided by N into 96500 whole divided by molar mass of C divided by N into 96500, right? So this is Na and this is Nc. Now if you divide this, 96500 will also get cancelled. So what I'll get? ZA by ZC is equal to Na, molar mass of A by Na, that is nothing but equivalent weight, right? Molar mass of A divided by Na is equal to equivalent weight of A by equivalent weight of C, okay. So that is what is formula given. M1 by M2 is equal to E1 by E2, okay. So now I hope this clear. Two formulas, two laws. Let us understand it again. The first law says that how much chemical reaction will happen, that will depend on the amount of current passed. If you are giving more current, more chemical reaction will happen, right? If you are giving less current, less chemical reaction will happen. Now due to this chemical reaction, what exactly is happening? Some mass is getting deposited at cathode. So if you give more current, more mass will deposit. If you give less current, less mass will get deposit, okay. So I can write one more statement here, that for the first law I can write here that when I am saying chemical reaction, that means mass deposited, okay. So now chemical reaction is proportional to the current passed. So more current passed, more chemical reaction, more mass deposited. Less current passed, less chemical reaction, less mass deposited. Getting? Okay. So here then second law tells that if you are having two electrolytic cell and you are passing current through it, same amount of current you are passing, then the mass deposited on the first one by the mass deposited on the second one will be equal to their equivalent weights, okay. So yes, now we will solve a question quickly, okay. Question number 1. How many coulombs of electricity are required for the reduction of 1 mole of MnO4 minus to Mn2 plus, okay. So now here you should remember that coulombs, okay. Here we have to remember what is 1 mole of electron. 1 mole of electron charge is called as 1 Faraday, which is equal to 96500 coulombs, okay. That you have to remember. 1 mole of electrons is equal to 1 Faraday, which is equal to 96,500 coulombs, okay. Now let us do this question. So MnO4 minus to Mn2 plus. Let us write the reaction here. MnO4 minus to Mn2 plus Okay, so now what is the charge of manganese here? If you see, manganese has a charge of +7 here, right? +7 to +2. So that means 5 moles of electrons have been used. So 5 moles of electrons are required. 5 moles of electrons are required to convert 1 mole of MnO4 minus to Mn2 plus. 5 moles of electrons means I can write 1 mole of electron is 1 Faraday. So 5 Faraday. Now 1 Faraday is 96500 coulomb. So 5 Faraday is 5 into 96500 coulombs. Okay. So now if you solve this, we'll get 40, this one, right? So 4 point, I'll do it calculation. Sorry, one small mistake will, okay. So we have 5 5s are 25, 5 6 are 30, 32, 5 9s are 45 plus 3, 48. Okay. So we'll get 48.25. We can see 10 to the power of 5, 1, 2, 3, 4, 5. So 4.82 into 10 to the power of 5 coulomb. So the correct answer for this question will be option number C. Okay. Now I'll see the next question. A certain quantity of electricity, so which law we have used here? We have used fire. Okay, this is just a calculation of how many moles of electrons have been required. Such type of questions have been asked repeatedly in your KCET examination. Okay, you need to practice such questions more. Okay, now let us go to this question. A certain quantity of electricity is passed through an aqueous solution of AgNO3 and cupric salt solution connected in series. So whenever it is said that connected in series, that means current is same. Okay, current is same. Okay. Now the amount of silver deposited is 1.08 gram. The amount of copper deposited is how much? Okay. So we know this is Faraday's second law formula, right? So what is Faraday's second law formula? M1 by M2. So I'll write the name of the elements. Copper deposited is asked, right? So I'll write it in this way. Mass of copper deposited by mass of silver deposited is equal to equivalent weight of copper by equivalent weight of silver, right? Now what is the mass of copper deposited here? And mass of silver deposited is 1.08 gram. Okay. Next, equivalent weight of copper is, how to calculate equivalent weight? So if you remember, equivalent weight is molar mass divided by N, right? So for how will copper get deposited? Copper will get deposited, Cu2 plus by plus 2 electron will give you copper, right? So now what happens if you see this one? Okay, now we have this cupric salt. Okay, so now what we can do? N factor is 2 here, so I'll write equivalent weight of copper is 63.5 by 2. Okay. Now how will silver get deposited? If you know, silver is Ag plus 1 electron is giving you Ag. So equivalent weight of silver is molar mass by N factor is 108 by 1. Okay. So now you can substitute here. E of copper is 63.5 by 2. And then this one is your 108 by 1. Okay. So now if you solve this, we will be getting around 0.3177 gram. Okay. So the correct answer for this question will be option number B. Okay. So in this way you can solve this question, very simple one, to get the answer for this question. Okay. Now let us do one more question. So this what we have used here, Faraday's second law, right? Okay. Now let us see next question. A current of strength 2.5 ampere was passed through copper surface solution for 6 minutes and 26 seconds. The amount of copper deposited is, atomic weight of copper is given, 1 Faraday is given. So here you see there is no series type things or one mass deposited, another mass is asked. If such type of things is not there, then you can easily guess it is from Faraday's first law, right? This is from Faraday's first law. Okay. So now let us try to solve this one. Okay. So first of all, let us note down the data is given. What is given? Current. Current is how much? 2.5 ampere, right? Current is 2.5 ampere. and the time is how much? 6 minutes and 26 seconds. So I'll cover it, I'll complete it, like convert it into seconds. So 6 minutes means 360, 360 is 386 seconds, right? 6 minutes and 6 into 60, 360, 360 plus 20, 380, 386 seconds total. Okay, next what I have to find the mass of copper deposited, okay? And so I know what is Z for copper, we'll also calculate that. Z for copper is, Z formula is molar mass by N into 96500, right? So now here what happens, molar mass of copper is 60, if you know copper, I wrote the reaction, 2 electrons will give you, so N factor is 2 here, so 63.5 divided by 2 into 96500, okay, 63.5 divided by 2 into 96500. So now if you calculate, now if you want to calculate the mass deposited, okay, so mass deposited M will be equal to Z, that is 63.5 divided by 2 into 96500 into current here is 2.5 and then time here is 386 seconds. Sorry, 386. So that is okay. So now if you solve this, you can calculate the value here. Okay, so if you solve this, you will be getting around 0.3175 gram. Okay, so the correct answer for this question will be option number A, 0.3175 gram. Clear? So this is also very simple and direct formula based questions. You can expect similar questions in your KCET examination as well. Okay, now let us move forward here. Coming to products of electrolysis. Okay, what is this products of electrolysis? So whenever any electrolytic cell we are taking, right? So I'll draw here just to explain. See, electrolytic cell we are taking, 2 rods are there, and here some electrolyte is taken. What is electrolyte? Electrolyte is any solution which can conduct electricity, right? So now what happens when you connect it into battery, this is positively charged, this will negatively charged, this will have a positive ion and a negative ion, so these will move towards the opposite electrodes and some product will be formed at each electrode. Okay, so for certain electrolytes, what are the different products formed, you need to remember. Okay, so here also you just need to remember the products at anode and cathode. No need to remember these reactions. Okay, reactions are not required. You need to remember for different electrolyte, what are the products at anode and what is the product at cathode. Okay, so for example, for molten NaCl, okay, I'll just explain what is molten NaCl. Molten NaCl means there is pure NaCl. Okay, so we do not have any water content in that. Okay, so now if you have pure NaCl, so it will be Na plus and we have Cl minus, right? So now if I told you like Na plus will move towards what? Na plus will move towards anode. Sorry, it is positively charged, right? So it will move towards the negative electrode cathode. Okay, and this Cl minus will move towards the anode. Okay, at anode what will happen? It will undergo oxidation. It will undergo oxidation and will form chlorine gas. Okay, and Na plus will undergo reduction and will form sodium metal. Clear? Similarly, when you take aqueous NaCl, so we have Na plus and we have Cl minus. Aqueous means water is there, H plus and OH minus. Okay, so now these two will move towards your cathode and will get reduced. So hydrogen has more reduction potential than sodium. So what will happen? Sodium plus will not undergo reduction, rather hydrogen will undergo reduction and will give you H2 gas. So now you understood, if you take molten NaCl, the products are different, but if you take aqueous NaCl, the products are different at cathode. If you compare for at anode, Cl minus and OH minus, oxidation will take place. So chlorine has more tendency to get oxidized. So that is why chlorine gas will form. Clear? Understood? Now these reactions, again I told you, the reactions you can see like chlorine has undergone oxidation by losing 1 electron. At cathode, this hydrogen has gained 1 electron and undergo reduction and gave you H2. Okay, so you just need to remember these gases, what is produced at anode and what is produced at cathode. Next, similarly, if you take dilute H2SO4, okay, dilute H2SO4, then cathode H2 gas will be produced, anode oxygen gas will be produced. If you take concentrated H2SO4, at cathode you will get H2 gas, but at anode you will get S2O8 2 minus gas. Okay, so these are the products. Mostly you have to remember this one is important and this one is important. Okay, these two are important, from where we can get more questions. Clear? Okay, now coming to next one here. Okay, here a question again, let us solve. In electroplating, the metal to be electroplated is made up of. Okay, so what happens when you are taking when you are doing electroplating? First let us understand what is electroplating. Electroplating means, okay, coating a metal with another metal. Coating a metal with another metal. Okay, so now what happens? Suppose I'll tell you that you have taken a chamber, okay, and you have taken two rods. Okay, one side it is positive and one side it is negative. Okay, so now what happened? You wanted to coat, for example, this is your any iron rod, okay, and you want to coat it with zinc. Okay, you want to coat this rod with zinc. So you should take zinc on this side and iron on this side. Now why this happens? Let's see here. So what will happen? At anode oxidation will take place and at cathode reduction will take place. So what will happen? Oxidation means zinc will undergo oxidation and it will come out of the rod as Zn2 plus, right? And this Zn2 plus will go here and undergo reduction again and will form zinc. So what will happen? This zinc will get deposited here, right? So like this, a coating of zinc will form on this particular iron rod, and this is a method of prevention for corrosion. Okay, so in this way what will happen? This rod can be prevented from corrosion. Getting? So now what is the question then? The metal to be electroplated. So here I want to electroplate or I want to coat iron metal. So to the metal to be electroplated should be taken as cathode. Okay, from the anode metal will dissolve in the solution and from there it will go and deposit in the metal in the cathode. So the correct answer for this question will be option number A. Okay, now coming to next one. During electrolysis of concentrated aqueous NaCl solution, the gas produced at cathode. So just now we have seen, right, at cathode which gas will be produced. So at cathode the in aqueous solution is taken. So at cathode hydrogen gas will be produced, right? So the correct answer for this question will be your hydrogen gas. Now let us do, okay, so now we have already studied galvanic cell in our part 1, right? And now we have completed almost electrolytic cell here in this part. Now let us have a comparison between them. What is the difference between these two? Okay, this is very, very important to understand. So here I have listed some of the difference important points. Okay, so the first one here is a galvanic cell produces electricity by the chemical reaction occurring inside the cell. Okay, so due to this some chemical reaction, electricity is produced, that is chemical energy is converted to electrical energy. And here what happens? An electrolytic cell requires electricity to drive chemical reaction inside the cell. So here electrical energy is converted to chemical energy. Okay, now the next point. So it converts chemical energy to electrical energy, it converts electrical energy to chemical energy. Okay, now coming to the third point, the reaction in galvanic cell is spontaneous and here it is non-spontaneous. Obviously we are supplying electrical energy in this case, so it will be non-spontaneous. Next, cathode is positive here and anode is negative, but here anode is positive and cathode is negative. Okay, next, ions are discharged at cathode while on anode they are consumed. Okay, so what is happening here? If you see in galvanic cell, zinc, right? Suppose zinc in the Daniel cell, if you remember, from zinc the ions were coming out, right? So ions, they were coming out from the anode and at cathode they were getting deposited. So now ions are discharged at both the electrodes in case of electrolytic cell. Next, electrons move from anode to cathode through the external circuit. Here electrons move from cathode to anode through an external circuit. Okay. Here movement of electrons is from anode to cathode. Here it is from cathode to anode. Next, half cells are set up in different containers. Here electrodes are kept in the same container. Okay. Next, electricity produced is as a result of chemical reactions, and it is measured by coulometer, and the EMF of the voltage provided to the cell is measured by the potentiometer. Okay. And the next one, galvanic cell has its application in batteries. Electrolytic cell are used in the purification and electroplating. Okay. So electroplating, just now we have discussed a question how the electroplating is done. So here in those type of cells, electrolytic cells are used, and in batteries, the batteries were used in your remote, in the phone, in different other appliances. That is your galvanic cell. Getting everyone? Okay. So this is a small thing that you just need to know, certain differences between galvanic cell and electrolytic cell. Okay. So I hope all of you are understanding what all discussion we have dealt in now. So we have discussed electrolytic cell. In that we have discussed two laws, Faraday's law, first law, and Faraday's second law. And then we have discussed products of electrolysis. There also I told you which are the most important that you must remember. Okay. Fine. Now we will move towards the next topic, that is conductance of electrolytic cell. So sorry, here I'll make a small change. It is conductance of electrolytes. Okay. Conductance of electrolytes. Okay, is it visible? Okay. Conductance of electrolytes. Now what is electrolytes? So the conductance of electricity by ions present in the solution is called as electrolytic or ionic conductance. Okay. So what generally we have studied about metallic conductors, right? Metals are good conductors of electricity, but there are some electrolytes, there are some solutions which contains ions in them. These type of solutions are called as electrolytes, and they can conduct electricity. Okay. So the conductance of electricity by ions present in a solution is called as electrolytic or ionic conductance. Okay. So now we are going to study about the conductance of these electrolytes. How do they conduct electricity? What are the different formulas? What are the different terms that is used, that we will be knowing now. Okay. So what are we going to study? We are considering electrolyte. Okay. So what is a electrolyte? Electrolyte is a solution which can conduct electricity. Now why does it conduct electricity? Because it has ions. Okay. So we are going to study how a electrolyte conducts electricity, how much it will conduct, what factors it will affect. These all things we will be going to cover now. Okay. So yes, factors affecting the electrolytic conductance. So first one is your nature of the electrolyte added. So which electrolyte you are taking, whether it is a strong electrolyte, whether it is a weak electrolyte. So on the basis of that it will depend whether it is a good conductor or it is a weak conductor. Next, size of the ions produced and their solvation. So remember, size of the ions produced. Where if the ion size is small, then it can conduct better. Okay. So remember, if the size is small, okay, if size is small, okay, the ion's size is small, then it will conduct better. Then it will conduct better. Okay. Next, the nature of the solvent and its viscosity. So when these electrolytes must be dissolved in something. Okay. So the solvent which you are taking. So another factor here, solvent, that is solvation, that is also you should remember. Solvation means what? Ion is solvated or is covered by water molecules. If solvation is more, then the molecule will become heavy and it will walk slowly. It cannot conduct fast, right? So solvation should be less, size should be bigger, size should be small. Okay. Solvation plays a very important role in the conductivity or in the conduction of the electricity. Okay. Next one is the nature of the solvent and its viscosity. So if it is a very viscous solvent, then ions cannot flow fast. If it is a very less, like you can say less thick solvent, then ions can move faster. Okay. Next, coming to concentration of the electrolyte. So how does this affect? We will talk in detail. Next, temperature. So if temperature is increasing, then the generally conductivity of the electrolytes increases. Okay. So these are different factors you should remember. Here also MCQs have been asked in the previous year questions, like which of the factors will affect, which of the factors will not affect. So these type of questions are asked. So yes, I have got you a question like this. Which of the statements about the solution of electrolytes is not correct? Okay. So conductivity of the solution depends upon the size of ions. Just now we discussed it depends. So this is correct, right? Conductivity depends on the viscosity of the solution. Just now we discussed it depends. So that is also correct. Conductivity does not depend on the solvation of the ions. I told you it depends on the solvation of the ions. So this statement is wrong. Okay. Next, conductivity of the solution increases with temperature. So just now we discussed when the temperature increases, the ions move faster, they conduct electricity faster. So that is why conductivity increases. Okay. Fine. So that is why you have to just remember these factors, small points you should remember about these factors. Okay, now coming to important terms, definitions and symbols. So these are the terms that we need to remember for understanding the conductivity of the electrolytic solutions. Okay. So now what happens here, see, I'll be talking about them each and every term here. First is resistance. What is resistance? Resistance is something which opposes the flow of current, right? And it is denoted by the symbol capital R, and its unit is either you can write it as it is represented in this way, or you can write OHM, ohm. Okay. Next, resistivity. Resistivity is what? It is denoted by the symbol of rho. The resistivity of a substance is the resistance when it is 1 meter long and its area of the cross section is 1 meter square. So a particular substance, if its length is 1 meter, area is 1 meter square, and whatever resistance it faces, that particular resistance is called as resistivity. Okay, and it is denoted as ohm meter or ohm centimeter. Next, coming to conductance. Conductance is just inverse. It is represented by letter G. It is the inverse of resistance. So the formula of conductance is 1 by R. So you can see just opposite of this one, ohm inverse, right? Ohm inverse can also be written as Siemens or S. Next, coming to conductivity, kappa. So conductivity is conduction by electrolyte per unit volume. Suppose you have taken, see, I'll just explain this one very in a layman term. Okay, you have taken a electrolyte. Okay, suppose you have taken 5 liter of electrolyte you have taken. Now per unit volume in this 1 liter, okay, how much electricity is conducted by this 1 liter of electrolyte? That is what is called as conductivity. Conduction by electrolyte per unit volume. In 1 unit volume, how much conductivity is there of a particular electrolyte? That is called as conductivity, denoted by the symbol kappa. Okay, this we call as kappa, and its unit is ohm inverse, meter inverse, or ohm inverse, centimeter inverse. And I told you ohm inverse is also told as S or Siemens. So I can write S meter inverse or S centimeter inverse. Clear? Next one, cell constant. Cell constant is G star, represented as G star, and its formula I'll write here. It is L by A. Okay, what is L? L is length and A is area. L by A is your cell constant, and what is the units here? Meter inverse or centimeter inverse. Okay. Next, coming to molar conductance, denoted by lambda m, and what is the meaning of this one? Conductance of all the ions produced by 1 mole of an electrolyte in a specific volume of the solution. So suppose you have taken, so here you need to consider 1 mole of electrolyte. Okay, so you have taken 1. Okay, so you have taken 1 mole of electrolyte. Okay, in that some ions will be produced. So whatever is the conductivity of this 1 mole of electrolyte, that is called as molar conductance. Clear? That is called as your molar conductance. Okay, now we have understood these all terms. Let us revise it once again. Okay, students, very important, you need to learn the symbols. Okay, that is where many students get confused, which term is asked, which term is asked, given, which is asked, that everything gets messed up. You do not understand these terms. Okay, let's revise once again here. Resistance, capital R, and unit is ohm. Second, resistivity, symbol is rho, and units are S meter inverse or ohm meter or ohm centimeter. Next, conductance. Conductance is the inverse of resistance denoted by letter G, and its unit is ohm inverse, or you can say S or Siemens. Next, conductivity. Conductivity is the opposite of resistivity, okay, and it is the electricity conducted per unit volume, and its SI unit is S centimeter inverse or S meter inverse, okay. And next we have cell constant L by A, its formula is meter inverse or centimeter inverse. Next we have molar conductivity or molar conductance, that is lambda m, and it is the electricity conducted by 1 mole of an electrolyte, and its unit is S centimeter square mole inverse or S meter square mole inverse. So out of these two, I tell you that you must remember this one and this one. Okay, this is very important. Must remember units, definition and symbols. Okay, these two are important, so please remember these two. Okay, now we'll go towards formulas. First is resistance. Resistance is R is equal to rho into L by A. Okay, so what is this rho? Rho is your resistivity. I will not write the terms here because just now I have discussed all the terms. So R is equal to rho into L by A. Rho is resistivity, L by A. L by A is cell constant, L is length, A is area. Okay, so okay, let me write down, otherwise you will get confused. So R is resistivity, okay, R is resistivity, L is length and A is area. Okay, next resistivity, rho. So from here can we write the formula of rho? Rho will become what? R into A by L, so R into A by L. Okay, next cell constant. Cell constant is your G star given by L by A. Okay, this part is called as cell constant. Next, coming to conductance. Conductance, I told you, it is opposite of resistance. So what will be happening? 1 by R, right? So I can write G is equal to 1 by R. But if I write the formula of this one, then what I'll get? A by rho into L, right? Just opposite of this one. Next, coming to conductivity. Conductivity is your kappa. This is very important formula. This formula you must remember. Kappa is equal to 1 by R into L by A. So can I write 1 by R as conductance? So this formula can be written as G into L by A, where 1 by R is what? 1 by R is G. And L by A is cell constant, so I can write it is further like this, that it is equal to G into G star, right? L by A is G star and 1 by R is G. So you can write it in this way also. Next, coming to molar conductivity, this is also very important formula. So these two formulas you must remember. It will be asked again and again, students. Molar conductivity is kappa into 1000 by C. Where what is C here? C is concentration. Okay, C is concentration. Lambda m is molar conductivity, K is conductivity, kappa into 1000 by C. Clear? Okay, now let us move to the next one. Question here again. Which of the solutions has the highest conductivity, means highest kappa value, right? So here you should remember that strong electrolytes will have more conductivity, weak electrolytes will have less conductivity. Now what is then strong electrolyte and weak electrolyte? So let us discuss first that one. So strong electrolyte means, okay, strong electrolyte means that electrolyte dissociates completely. Okay, and weak electrolyte, what is the meaning of weak electrolyte? So in weak electrolyte, that there will be partial dissociation. Okay, so there is partial dissociation. Okay, partial dissociation of what? Of ions. Electrolyte, I just told you, electrolytes are nothing but they contain ions which can conduct electricity. So for example, if strong electrolyte is suppose NaCl. If you take NaCl, it will dissociate completely to give you Na plus and Cl minus, right? So this is an example of strong electrolyte. Now if you take weak electrolyte, example of weak electrolyte is all organic acids. CH3COH. Here you need to put a equilibrium sign, okay? It will not dissociate completely. So CH3COO minus and H plus. Okay, so this is an example of weak electrolyte. Now what happens, let us see. So I can just now I told you this is a weak electrolyte, so it will not have highest conductivity. We can eliminate this option. Now NaCl, KNO3 and HCl all are strong electrolytes. Okay, all are strong electrolytes. Now if all are strong electrolytes, then how to decide? The next factor, what was the next factor that we studied? Size of the ions, right? I told you smaller the size, faster is the conductivity. You can just think like this, a thin guy can run faster than a fat guy, right? A thin guy can run faster. So small ions can run faster and conduct the electricity. So if you see here, H plus is the smallest ion, right? The size of H plus we know, very small ion, so it can conduct electricity fastest. So in that case, the correct answer for this question will be option number D. Clear? I hope everyone is getting? Okay. Now let us move to next question. We have a lot of practice questions, students, so that we can understand this concept in whatever formulas we have written, we'll use each and every formula and do the questions. Okay. So the conductivity of saturated solution of BaSO4 is 3.06 into 10 to the power of minus 6 as centimeter inverse. Now you have to comment down and tell me what is this value, conductivity, which value is this one. I told you there are so many similar terms, resistance, resistivity, conductance, conductivity, molar conductivity, right? So it is very obvious that you will get confused. So that is why I have given you a sheet of formulas of terms and their names and their units. So from these units, can you tell me this is which value given? I want everyone who is watching down to comment this answer right now. Okay. So yes, if you have done, then this is your S centimeter inverse is your kappa value. Conductivity is kappa value. How much it is given? 3.06 into 10 to the power of minus 6 S centimeter inverse. Okay. Next, and its molar conductance is 1.53 in S centimeter square mole inverse. Molar conductance is also given. So if you remember, molar conductance is lambda m. How much it is? 1.53 into 10 to the power of, sorry, no 10 to the power is there. So 1.53 S centimeter square mole inverse. Okay. So now it is asking you to find KSP. Ma'am, we haven't studied anything about KSP, right? But if you have remembered, KSP is a subject, is a portion, sorry, not a subject, is a topic that we have covered in that was taught in our 11th standard, right? But many of you might have forgotten it, but I will discuss that in detail now. Okay, let us just discuss what is KSP, then we'll come here. Okay. So now, for example, if you have any salt, barium sulfate is given, right? Then how will barium sulfate dissociate in water? Ba2 plus, okay, and SO4 2 minus. So we will tell that solubility of Ba is 2 plus is S and solubility of SO4 2 minus is S. Then what will be KSP? KSP is solubility of Ba2 plus, or I can say concentration, and here also the concentration of SO4 2 minus. So if I take S into S, what I'll get? S square. Okay. So the solubility or the solubility product of barium sulfate is S square. What is this S? Nothing but concentration. Okay. So now what is our task? We need to find, so we know the formula of KSP is S square for barium sulfate, but we need to find this S, right? Or we have to find this concentration. So let us do this question now. So what is molar conductivity formula? Kappa into 1000 by C, right? Now let me put this value here, lambda m is equal to, okay, I need to find C. So I can calculate C from here. So C is equal to kappa. What is the kappa value? 3.06 into 10 to the power of minus 6 into 1000, right? Kappa into 1000 by C. And then we have this lambda m value is 1.53, right? So now if you see, if we cancel, this is 2 and this is become minus 3. So I'll get C is equal to 2 into 10 to the power of minus 3, right? So now I'll substitute this one here, 2 into 10 to the power of minus 3 square. So I'll get 4 into 10 to the power of minus 6. So the correct answer for this question will be option number A. Clear? So just by knowing this one particular formula of KSP, we could have easily solved this question, right? I hope all of you have understood. Okay, now let us move to the next question. The molar conductivity of is maximum for the solution of concentration. Okay, again molar conductivity formula, lambda is equal to kappa into 1000 by C, right? Now what do you understand? It is asking different concentrations are given. It is asking in which case the molar conductivity will be highest. So from this formula we can say that if concentration is less, then molar conductivity will be more, right? Molar conductivity is inversely proportional to concentration. So you see where the concentration is least here. So obviously molar conductivity will be highest here. So the correct answer for this question will be option number B. I hope everyone is understanding. If you are not getting, please comment down whichever questions you are not getting. I will definitely answer it in my next class. Okay. Next, coming to another question here. So I have covered every formula that I have taught you. Okay, every formula I have taught you. So that is why you can understand these questions and practice them. Let's see the next question. The resistance of 0.01 m KCl solution at 298 Kelvin is 1500 ohm. If the conductivity of 0.01 m KCl solution at 298 Kelvin is 0.1466 into 10 to the power of minus 3 s centimeter inverse, the cell constant of the conductivity cell is. Okay, so now it is cell constant is asked. First let us note down all the data that is given. This is a method that you need to follow every time when you solve a question. Read the question once, second time when you read, note down the data that is given to you. Okay, let us start. Resistance of 0.01 m KCl. So I'll write concentration is how much? 0.01 m. Okay, then at 2 resistance is how much? 1500 ohm. Okay, next if the conductivity means I told you kappa value. So what is kappa value given to you? 0.1466 into 10 to the power of minus 3 s centimeter inverse. Cell constant is asked. Okay, fine. We need to calculate cell constant. So what is the formula we know? Kappa is equal to, what's the formula of kappa? 1 by r, right? 1 by r into L by A, right? L by A is nothing but cell constant. So can I say kappa into R will be your cell constant, that is L by A. What is the value of kappa here? 0.1466 into 10 to the power of minus 3, right? And I have S centimeter inverse, and then R value is 1500, right? 1500 ohm. So ohm. Okay, so just you need to multiply this one, right? So if you multiply these two, you will be getting around 0.219. Okay, so centimeter inverse. So the correct answer for this question will be option number A. Very simple, direct formula based question. The only thing you need to do is you have to practice these formulas. I'll tell you, do not mug up the formulas. Do not mug up the formulas at all. Make a formula sheet and start solving the questions. Whenever you solve the questions, just refer to this formula sheet. When you see again and again, you use it, you will remember it. Okay, so don't need to sit and read and mug up the formulas. Please do not do this process. Rather, do questions, keep a formula sheet, use that formula sheet, note down the formulas again and again, and while for every question I am writing the formula, right? So this only you should write the formulas, and then when you are writing the formulas again and again, definitely it will be printed in your mind. Trust me on this. Okay, next, then tell me whether it is working or not. Okay, so now we have done so many questions. So today what all things we have covered. Now let us have a small recap. First we learned about electrolytic cell. There we talked about Faraday's law, first law, and Faraday's second law. Next we talked about electrolytes, their conductance. We have seen so many formulas. The two important formulas I told you is conductivity and molar conductivity, kappa and lambda m. Next we are having variation of kappa and lambda m with concentration. Okay, so when I am changing those, I told you, when you remember when I told you factor, I told that concentration will discuss in detail, if you have remembered. So this is the time now we are going to discuss about molar conductivity and kappa, how does it change with concentration. Okay, very important thing, and a must PU board, so definitely this question is asked. Okay, I'll tell you. Fine. Okay. So first let us cover variation of conductivity, then we'll come to variation of molar conductivity. Okay. Okay. Now variation of conductivity. Here you can see conductivity. What is the definition? If you remember, I have written conductivity was, okay, conductivity is number of ions per unit volume. Number of ions per unit volume. Okay, number of ions per unit volume. Now let us see that we have a container, okay, and I had just, this is 1 liter. 1 liter volume is there. Now what will happen? There were, suppose, 5 ions were present. Okay. Whatever was the conductivity calculated here, that was your kappa at that time. Now what I did? I added more water. Okay. So I added more water. So now this is not the volume. So I will draw it like this. See. Now the volume is here. Now earlier this is your 1 liter mark. Okay. So we will not disturb that mark. This is 1 liter mark, okay, but now when I have increased the volume, okay, when I have increased the volume, these ions will start moving. When these ions will start moving, their position will be like this, for example, see. Okay, we will do 2 diagrams so that we can understand the difference here. See, suppose this was the first one and I had here 1 liter of electrolyte, okay, 1 liter of electrolyte, and I had 5 ions here. Okay, now I have added some water. Okay, so I have added another 1 more liter. So now it has become 2 liter. Now these 5 ions will not remain like this, right? You have added now more water. So this will be the condition now. Now you see, per unit volume, at that time how many ions were there? 6 ions were there, right? Now when you add it, the mobility, the ions will start moving. When the ions will start moving, now if you see, per unit volume is how many ions left? Only 3 ions are left. So where conductivity will be more? Conductivity will be here more and here it is less. So when you dilute it, when the concentration decreases, when the concentration decreases, the conductivity also decreases. Again, let me explain you once again. What is conductivity? Conductivity is defined by the number of ions per unit volume. Okay, so we have taken first 1 liter and I have added 6 ions there. Okay, they were moving and conducting the electricity. After that I have added 1 liter more. So now it became 2 liter. So when these ions cannot just remain in that 1 liter, right? They will spread now. They will start moving. So when they started moving, here we found 3 ions here, and this 1 liter, this is the mark, okay? In this 1 liter which was there per unit volume, now only 3 ions are left. So earlier there were 6 ions which were conducting electricity, and now there is only 3 ions which is conducting electricity. So where the conduction of electricity will be more? Definitely here. So I can say that when you are, so what you have added? We have added water, right? So you have actually diluted it. So diluted means what? Concentration has decreased, right? Concentration has decreased. So when concentration decreases, I can say that kappa also decreases. Okay. So conductivity always decreases with the decrease in concentration. Decrease in concentration means what? Dilution. Okay. For both weak and strong electrolytes, whether you take weak electrolyte, whether you take strong electrolyte, it doesn't matter. But whenever you dilute it or when you decrease the concentration means diluting. You can decrease the concentration only by adding more water. Okay, you have remember, like suppose for example you have prepared some juice, okay, Rashna's juice you have prepared. You have added more amount of that juice packet you have added. Right, you have squeezed more amount, it became very tangy. So now to dilute it, what will you do? You will add more water. So you are decreasing the concentration in that case, right? So that is what is called decreasing concentration means dilution. Please remember this one. So when I am saying decreasing in concentration, I am saying that I have diluted it. And how to dilute it? By adding more water. So when you are diluting it, or when you are adding more water, or when you are decreasing the concentration, the number of ions per unit volume also decreases. You can see per unit volume now only 3 ions are left. So if the number of ions per unit volume will decrease, then definitely conductivity will also decrease. Clear? Now this can be explained by the fact that number of ions per unit volume that carry the current in a solution decreases on dilution. Okay, number of ions per unit volume will decrease. That is why this one will also decrease. Okay, so now let's go to the next topic here. Okay, so once again, okay, so variation of now next one, molar conductivity. Okay, I told you molar conductivity. So for in case of molar conductivity, what happens? What is the formula of molar conductivity? That is equal to kappa into 1000 by C, right? Kappa into 1000 by C. So now what happens when concentration will, so I told you if you are adding water, then what will happen? That is dilution, and dilution means what? Concentration will decrease. So if concentration will decrease, molar conductivity will definitely increase, right? So molar conductivity increases with the decrease in concentration. You can see that from the formula directly. Molar, if you are adding water, okay, let us do more breakdown. What is concentration? Concentration is molarity, right? What is the formula of molarity? Number of moles per unit volume, right? When you dilute it, volume will increase. If volume will increase, concentration will decrease. If concentration will decrease, molar conductivity will increase, right? Clear now? Molarity, concentration is nothing but molarity. What's the formula of molarity? Number of moles per unit volume. If you are diluting it, you are adding more water, volume will increase. If volume will increase, concentration will decrease. Concentration decreases, molar conductivity will increase, right? Very simple one. So remember, kappa decreases if concentration decreases, but molar conductivity increases if this one increases, right? So once again I am telling, kappa will, if your concentration will decrease, kappa will decrease. If concentration will decrease, molar conductivity will increase. Okay, so I can write here, if concentration decreases, molar conductivity increases. This one we can directly explain from the formula itself, right? But for kappa we can understand it, per unit volume the number of ions decreases, that is why kappa also decreases. Okay, now this is because the total volume V of the solution containing 1 mole of electrolyte also increases. Okay, fine. So now let us go to this one. So actually there is a small, okay, coming to now. So in kappa, what we have discussed when we are talking about conductivity, when the concentration decreases, conductivity also decreases, both for strong electrolyte and for weak electrolyte. When concentration decreases, molar conductivity increases, both for strong electrolyte and weak electrolyte. But the increase is different in case of weak electrolytes and strong electrolytes. Okay, it increases differently. Let us see how. See. For weak electrolytes, what happened? Molar conductivity of weak electrolytes increases more. It increases both for weak electrolyte and strong electrolyte. But in case of weak electrolyte, it increases more due to the increase in dissociation of ions. Okay, just now we have discussed what is a weak electrolyte, where the ions dissociation is very less. Okay, that is called weak electrolyte. Now when you add more water, okay, these weak electrolytes starts dissociating. If they will dissociate, what will happen? Number of ions produced will be more. If number of ions produced will be more, the capacity, the current carrying capacity will increase, and that is why molar conductivity increases to a great extent. Okay, very high molar conductivity it will increase. Now if you talk about strong electrolytes, in strong electrolytes what happens? There is an increase, okay, definitely there is an increase in molar conductivity, but the increase is less as compared to weak electrolytes. In weak electrolytes increase is more, in strong electrolyte increase is less. The slight increase happens, why? Because the mobility of ions increases. Okay, mobility of ions means earlier what happens, suppose you have one positive ion and one negative ion, they will be attracted towards each other, so they were moving slowly. Now you added enough water, okay, suppose this was a positive cation and this was an anion. Now they were conducting electricity, the conduction will be very less because the ions are very close to each other, they cannot move freely. Now when you added enough water, here what will happen? If you add enough water, then these ions will move far away from each other, right? Now these can move, this can also move. Clear? Once again I want to repeat everything, listen in point wise. First point, when you decrease the concentration, molar conductivity will increase. Molar conductivity will increase both for weak electrolyte and strong electrolyte, but the increase will be more in weak electrolytes. The reason for that is the dissociation of ions will increase, more number of ions will start produced, as a result of which the conductivity will be more. In case of strong electrolytes, only the mobility has increased, number of ions has not changed. So the increase will definitely be there, but only a slight increase is there. Okay, so now that we can see through a graph here. So you can see here, this is a graph of weak acid CH3COOH, right? You see when you are decreasing the concentration, how steeply the graph has, how steeply the molar conductivity has increased. See, this was initially, I can say this is at 0.4 concentration, and when it is, the concentration is almost around, suppose for here some concentration is around 400. But if you see a strong electrolyte, the increase has only been this much, okay, only up to 200 it has come, but weak electrolyte you can see such a sharp increase is there. Okay, so now this graph we draw according to a equation that is called as your D by Huckel-Onsager equation. You need not remember this equation, but you just know lambda m is equal to lambda naught m minus a into root c. Okay, this is the equation. So graph is plotted between lambda m, this is your y, sorry, one second. Okay, so graph is plotted here, this is, I'll change the color, yeah, this is your y, okay, and this is your x. Okay, this is the slope, negative slope, and this is your y-intercept. Okay, so what is happening with concentration? This graph is plotted. Now there is one question about this A. Okay, so A is same for same type of electrolytes. Now what is the same type of electrolytes? I'll explain you with the question. Okay, so remember this one, I'll be explaining you with one question. Okay, now let us move. The question has come here. Okay, the pair of electrolytes that possess the same value for the constant A in D by Huckel-Onsager equation. Okay, now I told you that if the electrolytes are of same type, their A value will also be same. Okay, now what do you mean by same type of electrolytes? So if the charge of the cation and anion, okay, of both the electrolytes are of same type, then they are called as same type of electrolytes. We'll see with example. See, this is NH4 plus, this is Cl minus, this is Na plus, and this is Br minus. So here what is the cation charge? 1, this is chlorine charge is minus 1. So this electrolyte, the NH4Cl, we can call it as 1 electrolyte, and Na also plus 1, Br also minus 1. So this is also 1 type electrolyte. Okay, so this is also your 1 type electrolyte, right? So now both are 1 type, right? Because both are 1 type, they will have the same A value. Okay, now let us see the next one. Here Na is plus 1, Br is minus 1, so this is definitely 1 type, but Mg is plus 2, SO4 is 2 minus, so this is 2 type, right? So these two electrolytes are not of same type, so their A value will be different. Now coming to NaCl, NaCl again Na plus Cl minus, so this is again 1 type, and chlorine, calcium chloride, Ca is plus 2, chlorine is minus 1, right? When I'm saying plus 2 minus 1, I'm telling about their valencies. So calcium is plus 2, chlorine is minus 1, so it is 2 type, right? So again these two are different type of electrolytes, their A value will be different. Now Mg is plus 2, SO4 is minus 2, so this is 2 type, and here Na is plus 1, SO4 is minus 2, so this is 1 type. Right, so you can see where the electrolytes are of same type in option number A. If the electrolytes are of same type, then their A values will also be same. Okay, fine. Okay, now let us move to another next topic, that is Kohlrausch's law. Okay, what is the Kohlrausch's law and why is it required? Okay, so first of all we'll understand what is limiting molar conductivity. So we have understood one thing, that molar conductivity formula is kappa into 1000 by C. Right. So now if the concentration will increase, molar conductivity, concentration will decrease, molar conductivity will increase, that we have already seen. Now when the concentration increases to infinite dilution, means we have decreased the concentration to a very large extent, the concentration has almost reached 0. Okay, the concentration has almost reached 0. At that time, whatever is the conductivity, that is called as limiting molar conductivity. Okay, and it is denoted by this sign, one dot is given. Clear? When concentration decreases, molar conductivity will increase, but when you have decreased the concentration to a very large extent, that the concentration has almost reached 0. Okay, in that case, whatever is the molar conductivity, that is called as limiting molar conductivity. Now coming to, yes, this is the definition. When the concentration approaches 0, the molar conductivity is known as limiting molar conductivity. It is denoted by lambda naught m. Now what is this Kohlrausch's law? See, Kohlrausch's law says that limiting molar conductivity of an electrolyte can be represented as the sum of the individual contributions of the anion and cation of the electrolyte. Okay, so for example, if I have a electrolyte as NaCl, okay. So if I have a electrolyte NaCl and I want to calculate its limiting molar conductivity, that will be equal to the limiting molar conductivity of Na plus and limiting molar conductivity of Cl minus. Okay, suppose I will take about MgCl2. Okay, this limiting molar conductivity of MgCl2 will be equal to molar conductivity of Mg2 plus, okay, plus 2 times of molar conductivity of Cl minus. Okay, next if I talk about AlCl3, okay, molar conductivity here will be equal to molar conductivity of Al3 plus 3 times of molar conductivity of Cl minus. Why I am taking this 3? Because 3 chlorine is there. Why I am taking 2 Cl? Because here we have 2 Cl, right? So that is what Kohlrausch's law says, that if you have an electrolyte, its molar conductivity can be represented as the sum of the molar conductivity of the cations and anions. Okay, fine. So now what is the use of this Kohlrausch's law? So Kohlrausch's law, actually the application here is to calculate, so you can calculate lambda naught m using the Kohlrausch's law. Then Kohlrausch's law can be used to calculate alpha. Now what is alpha here? Alpha is degree of dissociation. Degree of dissociation, that is equal to lambda m by lambda naught m. Okay, lambda m by lambda naught m. Now here what happens? We can write it as K. This is used for weak acids. Okay, for weak acids. Now what is lambda m? This is molar conductivity. Molar conductivity, right? And what is lambda naught m? This is limiting molar conductivity. Okay, limiting molar conductivity. Okay, so that we can use. Now this is your K, this formula is used to calculate degree of dissociation. Then we can also use to calculate Ka, that is dissociation constant of an acid for a weak acid. What is the formula here? C alpha square by 1 minus alpha. Now you can substitute this alpha value as this one and then you can calculate this one. So majorly you have to remember this formula will be asked, important one. Once you get alpha, then you can use this formula and calculate the Ka. What is Ka here? Ka is acid dissociation constant. Acid dissociation constant. Okay. Now coming to another application of this one is to calculate lambda m for weak electrolytes. Now why can't we calculate, why not for strong electrolytes it is required, why it is required for weak electrolytes? So if you have remembered the graph, okay, if you have seen the graph, for strong electrolyte the graph was like this and for weak electrolyte the graph was like this, right? So you see, for strong electrolyte what will happen if we extend this graph? Okay, then we can calculate the lambda m. The y-intercept was lambda m, right? Lambda naught m. So if we extend for strong electrolyte, we can calculate. But for this one, you can see, even though we extend it, we cannot ever reach this line, right? So for weak electrolyte, we cannot calculate the limiting molar conductivity by extrapolation. Extrapolation means graph. If you increase the graph also, we cannot calculate. So the only method that is available for calculating of lambda naught m for weak electrolyte is using Kohlrausch's law. How? That we will see with an example. Okay, fine. So yes, here the example is there for you. Lambda naught m for NaCl, HCl and NaAc are given. Okay, so let us note down these values. Lambda naught m for NaCl means it is what? Lambda naught of Na plus and Cl. Okay, I'll write it like this. Na plus lambda naught of Cl minus, okay, lambda naught of Cl minus. Then we have lambda naught for HCl, okay, so that is equal to lambda naught of H plus and lambda naught of Cl minus. So I'll write the values also. What is the value given here? That is 126.4, and here what is the value given for HCl? 425.9. Okay, then we have for lambda naught for NaAC. Okay, so that is equal to lambda naught of Na plus lambda naught of AC minus, and this value is given to you as 91.0, that is S centimeter square mole inverse. Next thing is we have to calculate the molar conductivity of HAC. So which one is required here? Lambda naught of H plus and lambda naught of AC minus, right? So we have to collect these from these given data. Now you see where H plus is there in this one, right? So I will take this one. So I will take lambda naught of HCl. Okay, so what I'll get here? Lambda naught of H plus lambda naught of Cl minus. Okay, next I got H plus. Next I need AC. Where AC is available? Here, right? So we'll take this one, lambda naught of NaAC. So that will give me what? Lambda naught of Na plus lambda naught of AC minus, right? So this one I have got and this one I have got. So I'll get H plus and AC I am getting, but what extra is formed here? This Na plus and Cl minus, right? So that is why I will subtract this part. Lambda naught of NaCl, if I subtract, then what I'll get? Lambda naught of Na plus lambda naught of Cl minus, right? This is subtracted. So now if I solve it, what all things will get cancelled? This one will get cancelled, right? Now I am left with only H plus and AC minus, so I can get this value. So for this, what all things I have to do? I have to add HCl and NaAC. So that is 425.9, right? Plus AC is 91, right? Minus NaCl. NaCl value is 126.4. Okay, so if I solve this, I will be getting 390.5. Okay, so the correct answer for this question is option number D. So this is very easy. I have explained in detail, so we are filling it is very lengthy process, but you just need to see which all anions you need, cations and anions you need. H and AC is required, so you can add H and AC. The remaining whatever is there, that you can subtract it. Okay, so you will get this answer. I hope this is clear to everyone. Okay, now let us go to the some practice questions. Okay, so here this was a question that I have given in my last video, a homework question I have given you. An electrochemical cell can behave as an electrolytic cell when? So if the external circuit is more than the cell EMF, then the cell reaction will reverse. Okay, and in that case what happens? The electrochemical cell or galvanic cell will behave as an electrolytic cell. So this will happen when E external is greater than E of the cell. Okay, correct answer is option number C. Okay, now let us practice today's question. Okay, so this question, in a dry cell, which of the following is the electrolyte? Okay, so for this the answer is option number C, that is ammonium chloride. Okay, so I'll exclude this question. Okay, so let us see the question here. The specific conductance of 0.1 molar HNO3 is 6.3 into 10 to the power of minus 2 ohm inverse centimeter inverse. The molar conductance of the solution is. So yes, now what is the specific conductance? So you should remember specific conductance is same as conductivity, okay, or kappa. So now what is this formula? Molar conductance formula is kappa into 1000 by C, right? So what is kappa value? 6.3 into 10 to the power of minus 2, 1000 10 to the power of C, concentration is 10 to the power of minus 1, right? So now if you solve this, how much I'll get? I'll get 6.3 into 10 to the power of 2, that is 630, right? So you should remember here that specific conductance is nothing but conductivity or kappa. So the correct answer for this question will be option number C. Okay. Now let us see the next question. At a particular temperature, the ratio of molar conductance and specific conductance, again kappa, of 0.01 molar Na solution is. So let us write the formula here. Lambda m is equal to kappa into 1000 by C, right? They are asking you the ratio of molar conductance and specific conductance. So lambda m by kappa is nothing but 10 to the power of 3 by concentration is how much? 10 to the power of minus 2. So that I'll get 10 to the power of 5. So the correct answer for this question. Okay, here again units have to be very clear. What is the unit of this one? Molar conductance? S centimeter square mole inverse, right? And for kappa it is S centimeter inverse. So S will get cancelled. This one will go up, so I'll get centimeter cube mole inverse. So centimeter cube mole inverse, correct answer is option number A. Okay. Now coming to next question, the resistance of 0.1 molar weak acid HA in a conductivity cell is given to us. So let us first write down this data. Resistance is 2 into 10 to the power of 3 ohm, and then we have concentration given to you is 0.1 molar. Okay. The cell constant is also given, that is L by A. Cell constant is 0.78 centimeter inverse, and lambda naught m is given to you as 390 S centimeter square mole inverse. You need to calculate the pH of the solution. Okay. Fine. Here you should remember, for pH we need to know the H plus concentration, right? H plus concentration for a weak acid. Okay, this formula you might have studied in ionic equilibrium chapter of in PU1. So if you do not remember, I'll tell you H plus concentration is C into alpha. And do you remember we have studied in today's lecture how to calculate alpha, right? So alpha value you can calculate by getting lambda m by lambda naught m. So lambda naught m is also given to us. We need to find lambda m, right? So let us find. So I can tell you alpha formula is lambda m by lambda naught m, right? So let us do this question now. Alpha is equal to, first we need to find lambda m, right? So let us calculate lambda m. What is lambda m formula? Kappa into 1000 by C. Again kappa value is also not given. How to find kappa value? I know kappa is equal to 1 by R into L by A, right? So let us substitute this. So kappa will be equal to 1 by 2 into 10 to the power of 3, okay? And then L by A is 0.78, right? So how much I'll get this one? 0.39 into 10 to the power of minus 3. I'll substitute that here. 0.39 into 10 to the power of minus 3 into 10 to the power of 3 by, what is the value of C here? Concentration given is 10 to the power of minus 1. So this will get cancelled. So I'll get 3.9, right? So I got lambda m. Now let us calculate alpha. Alpha value will be equal to lambda m, that is 3.9 by 390. So I'll get 0.01. So I got alpha value also. Now I can easily calculate H plus concentration. So C value is 10 to the power of minus 1 and alpha value is 10 to the power of minus 2. So I'll get 10 to the power of minus 3, right? Now after getting H plus, what is the formula for pH? pH is minus log of H plus, right? So that is equal to minus log of 10 to the power of minus 3, and that is equal to plus 3, right? So correct answer for this question is option number D. So here a lot of formulas, I can say almost every formula we have used. First, by using resistance and cell constant we calculated kappa, but after getting kappa we calculated the molar conductivity. After getting molar conductivity we calculated the alpha value. After getting alpha value we calculated the H plus concentration. After getting H plus concentration we calculated the pH value. Okay, so I'll write step 1. First what we calculated? Kappa value, this is 1. Then we calculated molar conductivity. Then we calculated alpha value. Then we calculated, after getting alpha value I calculated H plus concentration. After calculating H plus concentration I calculated the pH value, right? Okay. Now coming to the next question. An aqueous solution of copper sulfate is subjected to electrolysis using electrodes. The pH of the solution will, okay, aqueous solution of copper sulfate is there, that means Cu2 plus and SO4 2 minus is also there, and H plus and OH minus is also there. It is undergoing electrolysis. So here you should remember that if copper 2 plus and H plus is there, copper 2 plus will undergo reduction. Okay, in last class we have studied that for hydrogen electrode, if H plus, okay, reduction of hydrogen, this reduction potential is considered as 0. For copper the reduction potential is 0.34. So this is having higher reduction potential. So copper will start to will undergo reduction. So that means what? H plus concentration will increase in the solution. If H plus concentration will increase, then what will happen to pH? pH will decrease, right? You know what is the formula of pH? Just now we have discussed. pH is minus log of H plus, right? If H plus concentration is more, then pH will be less. So the answer will be pH of the solution will decrease. Okay, fine. Now next one. Okay, so now let's have a small recap of all the formulas. Faraday's first law, M is equal to ZIT. Faraday's second law, M1 by M2 is equal to E1 by E2. Then resistance, R is equal to rho L by A. Rho is your resistivity. Resistivity we can arrange from here, R into A by L. Cell constant is L by A. Conductance is G, that is 1 by R, opposite of resistance. Conductivity is opposite of resistivity, so you can see 1 by A. 1 by R into L by A, this is important, please remember this formula. And molar conductivity, lambda m is equal to kappa into 1000 by C. Okay, so these all formulas I want all of you to note down in a formula sheet and use it whenever you are doing the numericals. Okay, next, so this is a homework question for all of you. Okay, you need to do this question, solve this question, and you have to comment down the answers to me. Okay, let's see how many of you are able to do it correctly. Okay. So yes, yes students, so that was the end of today's class. So we have discussed so many things, so many formulas. So just watch this video. If you have not understood any concept, watch it again. And if you have any doubt, please comment down, I will definitely address it. But remember, this chapter we will not leave it because 3 questions are asked from here, right? So we have to master this topic, we have to master this chapter. So yes, please read it thoroughly, understand each and every formula, and then practice these questions. Okay, yes, so one more thing, please join our WhatsApp channel. The link of this, the PDF notes of this lecture will be available in our WhatsApp channel. The link of the WhatsApp channel is there in the description section. Okay, so please don't forget to join the channel. And please, if you have liked the video, if you are understanding the concepts, if you are enjoying learning chemistry with me, then please subscribe the channel and like and share with your friends. Okay, all the very best. Keep learning and keep smiling.